Good morning, everybody, and welcome GDC Europe. My name is Matthew Steinke, and it's a pleasure to be here with all of you today. Before we get started, I just wanted to kind of quickly introduce myself. My first position was as a gameplay programmer, working on a third-person action-adventure game. Having worked in the industry now for over 10 years, I've had an opportunity to work on a number of amazing titles. Now, as a senior designer at CD Projekt Red, I've just finished shipping my latest title, The Witcher 3 Wild Hunt. And what a fantastic experience. Based on Andrzej Sapkowski's Witcher fantasy novels, players experience the adventure of Geralt of Rivia, a Witcher who sets out on a long journey across the lands of the Northern Kingdoms. Let's take a look.
At CD Projekt Red, it has always been our goal to take you on adventures both legendary and grounded in reality. To tell you stories where breathtaking magic, fantastic creatures, and age-old prophecies are interwoven with religious fanaticism, war crimes, even racism.
See her ears, she-elf.
It's this very vision that we've realized in our most ambitious project to date, the open world of The Witcher Wild Hunt.
Nice little start to the show there. As in the previous two Witcher games, players are presented with a core branching storyline that allows them to select choices that bear an associated and sometimes unexpected consequence. Featuring the power of the Red Engine 3, the title also focuses on delivering a deep role-playing experience across a vast open-world environment. And that's where I come in. My work focuses on what happens outside the storyline, what happens in the living world. Embracing the concept that every decision you make should impact the world around you, we set out to fill the world with interactive communities and nonlinear points of interest. Cities full of people, villages to save, random encounters, and places of power. While the living world continued to take on a life all its own, there was still one element missing: a gameplay mechanism to bind it all together: the economy. Giving a game an economy can bring it surprising depth and a life all its own, but like all living things, it can be difficult to control, and The Witcher 3 was no exception. Most of the features had yet to be started. What was there was fragmented and incomplete. We were talking about the design and implementation of core systems like the player inventory, merchants, and shop definitions, designing properties, location, localizations, artwork for all of the items the player will need to complete the game. Defining loot templates, balancing drop rates, placing containers in the world, equipping enemies the players must defeat in battle. Recipes for alchemy, where herbs can be used to create substances and powerful potions. Character skills that can be improved by augmenting the character with monstrous mutagens, and an entirely new crafting system with unlockable diagrams that allow players to construct new weapons, armors, and upgrades. Crafters that perform services like repairing gear that has been damaged, disassembling items, weapons, armor, and junk items. The system requirements were so extensive, and there was no time left in the project. To accomplish everything by the deadline, I needed to create a new system of game design that I called Witchcraft. And while it may sound like magic, Witchcraft is actually a system of tools, guidelines, and metrics that simplified the design process. It eliminated exploits, and it helped automate content generation. In short, it was my attempt to make a more scientific approach to designing the economy so that whenever possible, I'd be able to base my decisions on models of data instead of gut instinct. And that's what brings me here today. I've heard a lot of people talk about balancing game economies as if it were some unattainable goal only a PhD in mathematics could handle. But after my experience with the Witcher 3 economy, I found it to be like any other game feature. It's a lot of steps, but overall, a fairly straightforward process once I understood a few tricks of the trade. Now, as we continue our look back on the final months of The Witcher 3 production, I'm going to talk about some of the basic concepts I used to set up the economy before moving on to higher level topics like item design, price progression, and crafting system. As I do, I'll discuss some retrospective points regarding what went right, the design challenges I faced, and finally, some techniques that you can use to better your designs. Now, like many games, The Witcher 3 economy is based around the concept of money. And by money, I mean anything that can be traded for something else. If players acquire gear, upgrades, or even junk, those items are money. If players earn skill points that can be spent on character abilities, those skill points are money. Multiple currencies like crowns, orens, and florins, all are different forms of money. I mention this first because I believe it's very important to understand that money isn't what the player actually wants. It's only something like in our real world, a method for comparing the worth of two items, a means of converting what is happening in the game into something that the player wants. And this is important because I had specific goals for the economy. For instance, I wanted players to need money for purchasing food, ingredients, and upgrades, explore the world around them for new items, earning money from combat and loot they collect along the way. I wanted them to buy better items to improve their stats. Additionally, I wanted these items to cost more so that players would feel like they're earning lots of money by the end of the game. And to better visualize these goals, I sketched out a high-level state diagram to illustrate the system interactions. Defining system interactions in this way, it's easy to see what kinds of relationships we'll be creating between the player and the economy. For instance, one of the goals was to have the player explore the world for new items. In this example, we can see how this purchasing power is provided in the form of loot that is generated by winning fights and finding hidden containers. We can also see that new items can be purchased from merchants, allowing the player to upgrade weapons and complete sets of armor without having to find them randomly in the environment. Additionally, we can see how items can be equipped, dropped, and stored, sold to merchants for money that can then be used to purchase more expensive items. I like to think of this process as the cycle of spending, where by acquiring money, the player is able to purchase higher level upgrades that improve Geralt's performance. This allows the player to defeat more challenging objectives, thus earning more money to purchase better gear, and so on. To visualize this cycle's effect on the player's rate of growth, first I had to know how much each item cost. I started with basic items like herbs, junk, and books, as they seemed easy to price, but honestly, I quickly found myself guessing at what their actual values should be. Then there were usable items like swords and armor, where each item had unique qualities that the player could use during combat. To determine their price, I created a formula that calculated attributes like how much damage, defense, or healing each item provided into an overall combat rating I could use to rank other items in the system. Now, as you might expect, the abilities varied greatly from the type of item I was working with. To make the data more meaningful, I organized the list into inventory items and subcategories that best represented their use, filtering each range of data for parameters like the floor, average, and ceiling values. I was able to quickly evaluate the relationships between the category's ability, its price, and how each range compared to the others. The understanding led to a new set of rules and guidelines that specified how each category should be evaluated and adjusted compared to the others. For example, I wanted the steel swords to range from rusty and cheap to gnomish and expensive, but I also knew that they should remain less expensive than the steel relic swords that you can find. Steel swords should also be less in value than similar swords made of silver. Gloves should cost less than boots, boots less than pants, and all of them priced less than the chest armor for the set. Blending the subcategory types into 9 generalized categories, I was able to determine the final weighting for damage and the range of prices for each. To test the assumptions and visualize this data and how it fit all of these parameters together, I used the polynomial least squares fitting to chart each category's price progression. Now, from each curve, I could see exactly how the data was performing. Specifically, the rate at which spending was increasing as the quality of each item approached the category's ceiling value. This process identified anomalies in item pricing, and the curve acted as a recommendation from which I could make additional adjustments. While it often required several iterations to arrive at the curve I was looking for, I found this experimentation led to other results I hadn't considered before. For instance, see how the curve ramps up quickly and slows over time. Think about the impact that this has early in the game, where even a small increase in quality generates a large increase in the item's price. Was this the behavior I was looking to achieve? Did I want a linear progression or something more quadratic? Because The Witcher is so grounded, I had this impression that we needed to feel grounded as well. The economy needed to feel poor. You needed to be challenged and to need to work for what you earned. But I also wanted to know that items were going to increase in value so that when I reached that final relic sword, it felt like I was earning a lot of money and it was really worth the effort. With these goals in mind, I started to tune curves in a different way, one that reduced the rate of growth until the end of the game, where relic items would continue to increase greatly in value. While visualizing the data was a large step forward in predicting how pricing was going to affect the player's progression, I found these curves had other uses as well. For instance, by pre-calculating the coefficients and storing them in a table, I was able to procedurally generate this data at runtime. Now, instead of simply visualizing how a set of custom points fit into the curve, this functionality allowed me to generate an infinite set of points that fit the curve exactly. Not only did this change simplify my design process, it also generated content automatically. I eliminated hundreds of bugs and prevented new bugs from occurring. I had been spending weeks poring over thousands of lines of XML, hard-coded values that I was now able to remove from the pipeline completely, a process that reduced load times and decreased the footprint of every item in memory, an upgrade that saved me countless hours of crunch during a critical time in the production. By removing the guesswork and the random errors associated with custom content, every item was now consistently balanced in relation to the other items in the system. And with a ranked hierarchy of items, it made it easy to subdivide each category into specific level-based requirements that I could use to distribute the content across all the regions in the world. I could use that to determine what level the player should be in order to use that item. I could use it to create loot definitions, that would always reward the player with items that they could use. And I could equip NPCs with armor and weapons that kept combat challenging. With the system interactions defined and inventory items balanced, my next step was where to go next. Working on the third installment of the Witcher franchise, I knew I needed to stay true to the original, but I also wanted to create a fresh experience for fans of the series. And I also wanted to continue pushing this concept of player agency, the idea where the player is making choices that impact the story through gameplay. To do this, I redesigned the initial set of interactions to incorporate a crafting system. The basic idea was to create a solution where every item was constructed out of other items in the system. By refactoring existing technologies, I focused on a component-based architecture and implemented new features that allowed the player to craft new gear and upgrades, disassemble items into new component types and rare resources, repair items that had been damaged during combat, and remove upgrades to encourage experimentation with the various glyphs and runestones that they had available. With the crafting system in place, instead of purchasing a leather square or waiting to find one in the environment, players could now use the excess leather scraps in their inventory to craft one. Unusable junk items like a broken rake or a rusty sword, items that had previously been simply sold or discarded, could now be disassembled into a tree of other resources, including rare elements, alloys, and precious gems. The effect of this change on the economy was dramatic. Crafting items led to an emergent gameplay where each item now had a specific role to play. A virtual network describing the relationships between every item in the system. My only concern was that crafting equipment caters more to a hardcore gamer, and I was focusing on a mainstream audience that would primarily be joining the game for the story and the cinematics that they would be witnessing. To simply bring the learning curve and focus on the fun, I applied the concept of rational game design. Rational game design is all about eliminating unnecessary information, making things inherently readable, understandable, and apparent, introducing mechanics in an orderly and easily digestible fashion to establish a realistic learning curve for the player experience. To incorporate this philosophy, crafting diagrams were designed to lure players in with simple builds made from common components they probably already had in their inventory. For example, using 2 iron ore, you can craft 1 iron ingot. For players looking to craft better components and materials, diagrams were designed to build on one another, scaling in complexity by increasing the number of components required, the types of components used, the rarity of each component, and so on. Figuring everyone would eventually want to craft their own weapon, sword diagrams were slightly more challenging, requiring a minimum of 3 components. Higher-level swords often required rare precious gems, alchemical ingredients, and refined metallic alloys like dark steel, meteorite silver, and dim iridium ore. For the most hardcore fans, looking to capitalize on every advantage, armor diagrams started at 4 components, 5 for Witcher School relics, and require a wide range of materials including leather, metals, and monstrous remains the player must acquire by defeating powerful beasts in battle. And by incorporating this philosophy of rational game design, the crafting system was able to dynamically balance the difficulty based on the player's ability to keep the experience interesting from the beginning to the end, while providing a good level of challenge along the way. One of the challenges now that I ran into was the impact that crafting items had on my existing design. I was concerned that my pricing model was only based on damage and the item's combat rating, with no consideration of what an item was actually made for. If left unchecked, this would eventually lead to exploits where certain items might be disassembled into more value than the original item itself. What I realized at that point was what an item is costing, what an item is worth, and what an item should be sold for are often very different values. For example, to eliminate exploits with the disassembly process, I had to make sure the item's price was equal to the cost of the salvaged components it generates. But when determining an item's worth, as we all know, sometimes the whole is greater than the sum of its parts. Compare the worth of a relic sword to a piece of leather, a glowing ingot, and some dim iridium ore. While they may represent the same cost in crafting materials, the sword's ability to be used in battle increases its perceived worth considerably. Realizing there was more to an item's price than just the cost of crafting or how much damage it deals, I changed my method for determining price to combine all of the factors that I had available. Now, to calculate the item price, the cost of crafting materials was added to the damage-based ability cost I had been using. To calculate the sale price, this value was reduced by a durability percentage, representing the amount of damage the item had received. Finally, a price modifier was used to scale the sale price up and down based on a number of runtime parameters. And by price modifier, I'm actually referring to a larger concept that I refer to as economic drain. A function of the economy, this prevents the player from attaining infinite wealth. It affects the costs involved with common interactions. Price modifiers unfairly burden the player's budget and work to reduce the purchasing power over time. They increase the cost that crafters charge for their services, a progressive drain that scales with the quality of each item. They ensure that merchants will always sell for more and buy for less. And for this, I created a singleton to coordinate all price modifiers across the economy, a tool that I called Reactor. The power of Reactor came from its simplified approach towards how each modifier was determined. Instead of setting a static value, prices were calculated at runtime, making every trade unique, a living economy where each item had a different value based on the type of merchant the player was interacting with and the state of the world around them. This rewarded most ambitious players who might travel to distant lands to trade for different items at favorable rates. For example, in Skellige, a land where villagers are hardy and well-fed, grain and meat can be purchased at reasonably low prices. But if you were to travel to No Man's Land, where the region has been ravaged by war and famine, a player can trade for these same goods at a very, very large profit on their investment. To prevent the sale of an item, negative values were used to indicate where a merchant was uninterested in the trade. For instance, a blacksmith will give you the best rates for weapons and upgrades, but will not purchase books, junk, or alchemical ingredients. Creating a matrix of all possible values, I stored this data in a hash map, and it allowed me to retrieve any value at near constant time. Following a single pass in the editor to mark up each item and the merchant actors with their associated tags, a callback to getPriceModifier returned how each actor should react based on the given series of weighted percentages. While the crafting system and price modifiers like item durability created a more meaningful gameplay, they also presented new challenges to solve. For instance, repairing items that had been damaged is a great economic drain. It gets more expensive as items increase in value, and the player performs the action often. Even more importantly, it creates another point of decision where the player must choose whether to scrap it, buy new, or continue to fix it. The issue is that reducing damage creates problems for player progression, perhaps during a primary quest where, after a long journey, the player must defeat a powerful boss to continue. Even with preparation, the player may find it impossible to win because the item is no longer effective. While repair kits were added to help with this, they come at a cost and weigh the player down, which wasn't really fun. Inventory management became another challenge. Unlocking a wide variety of diagrams kept the crafting experience fresh, but with no way to predict what would be needed in the future, I found that players started hoarding items in their inventory. This created issues for the inventory size, which led to an overall decision to remove all restrictions in place. While this focused on the fun and supporting the player experience, it created problems for other systems like encumbrance, which simulates the player's carrying capacity. To resolve the issue, the weight of most items was set to 0, while gear like weapons, armor, and horse upgrades were still factored into this limitation. The change ultimately left the system in a confusing state. Unlimited inventory size also led to issues with inventory navigation. Part of the crafting process is that moment of discovery where the player unlocks a new diagram or finds a rare component they've been searching for. The problem with an unlimited inventory was that as the number of items grew larger in size, it became increasingly difficult to find the items you had just required, or even locate a specific item you were hoping to study. To simplify navigation, better filters have been developed to make items easier to find. But more work could be done, including sorting by level requirements and high-level changes to the user interface. Because of its role in the economy, loot generation was one of the toughest mechanics to get right and remains an ongoing challenge for the downloadable content we are currently creating. The problem is that while there are a number of ways to balance drop percentages, there's also a component of level design involved that makes it difficult to get right. To reduce the amount of random loot generation, specialized container classes with more intelligent behaviors determine when and what types of loot should be generated. Some example functions include determining the desired number of enemies per item set and desired number of items that should be dropped per level. And it was about this time that the game was finally shipping. While it wasn't perfect, the economy was balanced, challenging, and enabled the player to be a part of the story. Reading the reviews and comments posted to forums by players around the world, perhaps some sitting in this room today, has been one of the most rewarding experiences of this process. Hearing about your journey and how you've become immersed in the adventure is really the reason why I do what I do. Having spent weeks collecting your suggestions and your feedback, it's already led to a number of improvements in the design and led to elimination of multiple exploits, but there's still more work to do. And with episode 1 and 2 only weeks away, I'm looking forward to sharing all of these new features we have in store. Before I get back to it, I'd like to leave you with some general techniques I hope you can use to balance your game. As I started working on the Witcher 3 economy, one of the toughest questions I faced was where to begin. So to help you get started, I would recommend the following 3 ways to approach balancing your design. The first is to use math. And while math may be challenging, basing relationships in your game on curves will ensure that every result is balanced. The problem is that if your formulas or assumptions are wrong, everything in the game will break. And that makes it difficult sometimes to jump into rapid prototyping situations where you want to see results quickly. That's why it's important to use your instincts. Change the balance in the game until it feels right to you. Just remember that a gut instinct is vulnerable to human error. And because it's not absolute nor reproducible, different designers will produce different results. And this gets complex on larger projects where people might come and go, or different designers may be assigned to complete different tasks. To know if it works, use playtesting. Make your adjustments in the game not just based on what you think will work, but based on how it plays and how it feels. Use the results of experienced playtesters that are focusing on exploiting the system and making sure that they are playing to win. Just remember, though, that testers may not find every balance issue in the game, and that without some level of discovery, these issues can go unnoticed for weeks or even months. Also, make sure to iterate as you go. Make one change at a time. It may sound obvious, but I feel it bears repeating. If something breaks after making a change, you'll know exactly why. If something breaks after making 10 changes, you don't know which change or what combination of changes is resulting for it. If something can be taking the time that forces you to backtrack as you determine where things went wrong, I recommend you save yourself the time and wasted effort. Just simply make one change at a time and test often. Learn to love spreadsheets. I might be preaching to the choir here, but as I'm sure all of you already know this, but for those that don't, learn to love spreadsheets. Whether it's Excel or Google Docs, spreadsheets make it easy to maintain complex lists of game items and properties. Spreadsheets are great for keeping track of tasks, status, and the time remaining. They are good for collecting and manipulating statistics, generating random numbers, creating formulas, and running statistical simulation. Whether I am ramping up on a new design or looking to close on an existing one, the spreadsheet remains one of the most powerful tools in my arsenal. Use the rule of 2. When balancing economy, I find it's really a process of discovery. Whenever values in the game are off, I have to make changes and test new values to see what happens. The rule of 2 states that if you're not 100% sure of what that value should be, you should double it or cut it in half. Even though the final adjustment may only require a minor change, by doubling or halving the value, you may discover that it changes dynamics in a way that was unexpected and sometimes even superior to your original design. And of course, one of the best things you can do when balancing your economy is to write down your rules as you learn them. Inevitably, in my experience, I find that as I continue to balance the game, I'm going to have success, and of course, I'm going to make mistakes. While it's possible to learn from both, you're going to learn the most from making mistakes. And that's why when you find these rules, when you make these moments of discovery, it's best to define that metric or write that game design to create a new balance technique and record it to make sure that those notes are able to be reviewed frequently, something that you can come back to over the weeks and months as you develop. Unfortunately, very few designers actually do this. As a result, they do not pass on their experience to other designers, which often leads to similar mistakes simply because these lessons have been forgotten. In summary, the design and implementation of the economy for Witcher 3 Wild Hunt has been the preeminent learning experience of my time here at CD Projekt Red. While the initial design challenge was to create the living world experience with a balanced economy by utilizing existing assets and bridging the gaps between legacy systems, I was able to create something completely new. While I've shared many of the concepts and techniques that have helped me gain control over this system, I know it's easy to get lost in the details and forget the big picture. If this happens to you, I hope that you'll take a step back and think about your approach. Consider your two most meaningful decisions. How will the players earn money? And how will players spend the money that they've earned? Focus less on hard-coded values and more on understanding the relationships in your system. This is key to your success. Whenever possible, try to take a more scientific approach rather than acting on instinct alone. Build a cost-benefit ratio to where two objects are balanced because the proportion of their cost and benefits they provide are the same roughly for each. And as your system grows in complexity, use the concept of rational game design to keep the experience interesting from the beginning to the end while providing a good level of challenge along the way. Good luck to all of you. I think we have some time, so I'd like to open up the floor to any questions you might have. And I think the GDC helpers are going to be walking around with a microphone too, so if you can grab that, I think it'll help everybody here.
Hello, I would like to ask you about the difficulty curve for balancing the economy. Because from my experience, I played The Witcher on the most hardcore level, and I found out that I almost always have about 40,000 Novigrad crowns, and I can do nothing with it. When I get the new recipe or something like that, I see a drop, but soon after that, I have the same amount of money. Did you not have the time to balance it out for more hardcore difficulty, or you didn't care about this?
No, so as I understand, the question is basically how are we compensating for some of the runaway savings that players are generating? And by this, I would say this is an ongoing process. Definitely time has been a factor. Having started on the economy so late, I found that a lot of my time was spent just getting the system put together, making sure that it was bug-free and playable, more so than having a lot of time to review and play test to limit some of these runaway situations that you're describing. One of the things that we're doing right now is reviewing our loot generation. I think the problem was clear kind of a bit late in the process, but definitely something, again, that we're working on. That generating loot randomly means that you're going to be getting items that might be something far beyond your level. And these items, of course, are going to come with greater costs. Part of that leads to us kind of this awesome feeling where you feel like you've discovered like a rare flawless diamond, or you've seen a piece of crafting components that you really want to be able to use in the future, but you don't have a diagram to use it with right now. So it kind of just leads to this, what can I do next? What can I build with this? And while it's all great, again, it does generate this inconsistency where, as an early player, you should be only seeing things that you can use immediately, and that will also dramatically lower the price. The other thing is, again, this level design component that I have been speaking about, that because we have so many different teams, so many different designers working on placing and creating an environment that is going to feel real and alive, that part of this came with a massive amount of loot. As a result, if you're playing this, especially in a non-linear format, because it is an open world game, there's really no way from a design standpoint to control whether or not the player will just play through the storyline or if they're going to run around the world and collect every piece of gear that is available. It sounds like you might be one of these
that's me.
completionists. Yeah, and I'm the same way. I go everywhere. I lock every piece of the map. I try to collect everything before I move on. And so to some level, I was kind of needing to design a system that would defeat my play style. And again, part of this is just the limitation of time. It's not so much that I feel we don't have good ideas or we don't have the right approach. It's just more because of the random generation of loot, because of the high numbers of things that you can find, and without any limitations towards restricting what will be appearing in your inventory. Sooner or later, I think this generates this runaway effect that you're talking about. The other thing I wanted to mention about this is economic drain, along with working on the loot and the drop percentages. There's a real effort towards creating other avenues of spending. We're going to be releasing some great new features in Episode 1 that kind of go with this, so that if you do have all this money, you're going to be able to dump all of it, hopefully, into something that will also lead to more abilities to purchase things. And I think for me, that is one of these ongoing challenges. Just from a content creation standpoint, finding ways to get the player to interact with the world was limited. We have a lot in the beginning of the game, and you feel like, wow, I want to have the money to spend. I want to have the opportunity to get what I want. And then towards the end, you've got this money now, and perhaps there's not enough places to spend it. So I would say, these 2 or 3 ideas here all affect the player progression and your ability to spend. And it's just through these techniques that we will hopefully bring this runaway effect into control.
Thanks for your answer.
Yeah, great question.
Hi, great talk. So I got one question. So you talked about basically balancing the utility of certain items against its cost and coming up with a linear or nonlinear function.
Yes.
So I'm curious, so how do you deal with comparing utility of different classes of items? Say, you have a sword, right?
Yes.
How do you compare that to a new pair of boots? And specifically, did you use any feedback that you get from the game in terms of having a better armor kind of makes it as much easier to defeat a boss than having a better sword? Or did you use any feedback like that to kind of find balance and stuff?
Well, and for The Witcher, there's also things like mutagens, decoctions, potions, oils. There's like all of these other factors that all come into play. But for me, the common thread was damage. Damage, in a sense, is health. And if I took 1 point of health back, if I have 1 point of regeneration, if I have 1 point of damage that I deal, 1 point of damage that I resist, we're really still all talking about, in a sense, combat and my ability to mediate damage.
How about speed, like boots?
Yeah, speed. Well, I think speed is definitely one of those things that we didn't have a chance to kind of incorporate, but is another fantastic example of just a gameplay attribute and something that should be considered when determining an item's cost. It's this concept of worth versus the materials it's made of that I was trying to make. The idea that when you look at something and you're going to break it down into something else, to be able to translate these items into other items, this is all that's important. But when dealing with a merchant who wants to make money, I'm talking to a blacksmith where the whole idea is they don't want to buy my sword. They have a job making swords, so they're looking to move product. And they're going to want to keep this relationship more beneficial to them. And some players feel this is unfair, but at the same time, I feel like it kind of brings across a nice storytelling. All of these factors kind of come in, I think, to this relationship of how do you value something then? If a blacksmith is buying armor, does he even want armor? Does he want crafting components or rare crafting components that would allow him to make more valuable swords? I think all of these things are important to consider. And what I recommend is what I did, which is creating kind of a table of weighting percentages or just weights in general. The idea that if you have a value and you want to compare it versus something else like speed or like health regeneration or stamina regeneration or fire damage, frost damage, poison, right? There's this opportunity for you to evaluate what's most effective in your game, what's most effective when fighting. And if you maintain kind of this high-level relationship of what each one of these factors is and kind of how it impacts the others or how it performs in comparison to the others, then for me, this is how I feel you can go through, and it doesn't matter at that point what it is. You just adjust that weight and factor it into your equation, and when that cost comes out, it's going to be, again, balanced fairly with the same rules and restrictions as every other item in the system.
Great, thank you.
Sure.
Hi, great presentation. I have to say I'm working on a game and we're currently balancing the economy and the goal distribution, so this really came in handy. Really glad I was attending it. So my question is, you mentioned there were 3 components that you were tracking for item worth, like your charts, the math, your gut instinct, and also the player feedback from your QA department. So my question is basically, what happens when you have an item which kind of stands out a little bit because it's acquired from a certain opponent, which is hard to beat or something like that, and that doesn't really factor in with the math that shows you it should be worth this much, but the feedback you get from QA and your own gut instinct says it should be worth more because it's hard to acquire and it's hard to defeat this opponent. So how do you deal with those situations? How do you weight like your instinct over the math? That's basically my question.
For me, it was this concept of using the math to generate this curve so that I knew at least, all other factors aside, no matter what I felt or you feel or what I was getting back from QA, there is this baseline that was equivalent. Starting from there, there was this, I guess what we kind of call the gap cost. And that gap cost isn't finite. There's no real basis for what exactly it's worth. At that point, if you can, kind of like we were just saying on the last question, what I would recommend is trying to evaluate what exactly its attributes are and the benefits that it's providing, with the rationale that if you do, even if it's only an approximation, you at least have something that you can go back to and adjust and compare to the other items that might need this type of relationship, this additional gap cost that makes them feel so worthwhile. And for me, I don't know if I've totally answered your question on that, but I feel like that's kind of the concept involved, that there's really no right answer for that you just have to look at your game. You have to look at the gameplay mechanics involved and the experience that it's giving you as a player, and that instinct is going to be an additional sum in addition to the math involved. It's not for me like a one or the other. It's a combination of both. And at that point, you could end up with something like a 10,000 crown sword or even a 20,000 crown sword if you feel that that's what tells the story that you're looking to tell.
Thank you.
Sure.
Hello? Oh, it works. Hey, dudes. I'm a mobile game designer, and when we're designing monetization around mobile games, we're always concerned about average playtime, session lengths, and all that kind of stuff. So I was wondering, since you have an open world and there's a lot of human factor into it, do you also factor in the farm time when you're balancing your economy?
The farm time?
Yeah.
I feel like this is part of loot generation. That if I'm going through and I have a series of containers on the level, that if possible, I can arrive at kind of this number of how many containers are out there, how much experience the player will need in order to acquire a level, and then start looking at other relationships like how many items I want them to gain per level, how many items I want them to gain maybe per hour. And by defining different metrics, by understanding the rate at which I want the player to grow, this is how I feel you can factor in the concept of farming, so that if somebody is just trying to progress too quickly or they're not evolving the storyline, that we don't want to penalize them exactly, but at the same time we can moderate how fast they are able to exploit this system. And still give them the challenge and the fun that they're looking for.
Thank you.
Hello.
Hi.
All right. My question is this working? Yeah. Okay. Sorry. You said that you've implemented the infinite inventory to prevent the problems with burden and such. Have it stricken you as a bit inelegant solution? I mean, would you consider, like, I don't know, pools for the crafting materials as a separate entity, not accessible to the player? You can just either have item in inventory or break it down into crafting elements to present less information to the player, so he doesn't have to browse and go through filters and whatnot.
Yes, I think that the design decision at the time was made as we were closing the game, and that time was the major deciding factor. There were a number and are a number of ways that we are currently looking to change this going forward. Ways that I feel are more intuitive for the player, like you said, maybe even more intuitive when sorting through these large numbers of assets. And this is something that I think we'll be exploring in the months to come. The idea that, you know, the unlimited inventory size does impact other systems like encumbrance, like the item's grid size, you know, this concept that some things are only one box, some things are multiple boxes, and you're supposed to be able to fit them all into the grid, like almost like Tetris. You know, these are all compromised by this unlimited inventory size. So perhaps, you know, and there's even a lot of concepts or comments and suggestions on the forums about having a container or a storage chest or having different guilds where you're able to unlock something from having earned the ability to just get it at any time that you want. And as a result, this would also remove the need for such massive inventory. These are all, like I say, possible. These are all things that we are willing and looking to explore. It's just at the time something we didn't have you know, resources to investigate.
Thank you.
Yeah. Any other questions? Okay. It's been a pleasure. Have a great GDC, everybody.